Cathodic Protection Training Course, Introduction to Module 01. Cathodic protection is a way to control corrosion that causes pipelines to leak and the owners to lose billions of dollars. This causes whole countries to go into recession and ordinary people to lose their jobs and their homes. An example of this is the leak of the Nord Stream pipelines that has caused German industry to fail and the depression that is spreading all over Europe. Corrosion is governed by the laws of nature and controlled by understanding these laws. Scientists then use these laws to the benefit of everyone through engineers who physically apply the idea to control electrical energy to make the lights come on, and when we switch them, and batteries to power our computers, torches and electric vehicles. My job is to present all of the information you need to learn and understand the science of corrosion control. Module 01 is deliberately basic in order to explain the laws of nature that govern us all and help students to understand the gobbledygook that is taught conventionally, as in the picture below. When we first get paid as CP operatives, we must be able to relate scientific theories to the actual displays on our instruments and the data that we record during field surveys, such as this form, as you can see, which field technicians will be familiar with this sort of thing, where they have to record the data that they are taking in the field. This module includes practical work that is designed to enable the student to understand how to examine this information and form their own opinions about the basic principles that they have been taught. Since 1980, cathodic protection data has been stored in computers, but the difference between the electrochemical theory and most basic field practices has made it impossible to achieve computer analysis. All that is done at present is to display graphs and voltages that are interpreted by people who believe that protection has been achieved when a voltage of negative 850 millivolts has been measured between the copper sulfate ground contact electrode and the electrical contact point with the pipeline, tank bottom or other buried or submerged metal structures. This picture is of one of the very first recorded surveys of the on-off potential, the close interval potential surveys. It is important that each student understands this module as the basis on which they can move forward. At the end of the course, each student will be required to present a paper for publication on the CPN website. The merits of each paper will be assessed by the membership of the Cathodic Protection Network. Experienced corrosion engineers and scientists will be able to check the validity of each step and are encouraged to explain their opinions. This course has been online for many years now and has had many thousands of visitors. There are now many interactive students. This page has received over 76,000 hits during this past year. From discussions on a variety of social and business network groups, it can be said that these pages are being used as a sort of reference book. But this is not helping to advance the practical application of cathodic protection, as many asset owners are working to the standards set by the National Association of Corrosion Engineers and the Institute of Corrosion. They are not based on science. I am now working my way through this course to make it clear that it is essential that students start at the very beginning and do not move on until they thoroughly understand each module. I have received many reports as required for Certificate of Understanding and Ability, and so there are now many of us reviewing other reports that are being submitted. Software engineers who want to develop diagnostic software for cathodic protection and corrosion control need to understand the laws of nature that apply to our science. This module is very important to everyone with the application of cathodic protection because it clarifies the measurement known as the pipe-to-soil measurement, that is sometimes abbreviated to PSP, as shown in this picture. The pipe-to-soil potential is quoted in almost all papers, and discussions relating to cathodic protection and the control of corrosion to steel pipelines and facilities. Cathodic protection has always been divided between the science of electrochemistry and the application of cathodic protection technology in the field. The measurement that we require is defined in scientific codes of practice applicable in laboratories where it is possible to control all conditions in a closed circuit measurement. This picture shows DIN 50918, which is a specification for the measurement of the electrochemical reaction. In cathodic protection network, we refer to the working electrode as the anode and the return electrode as the cathode. The reference potential in the diagram is the hydrogen electrode, and the IR drop is not the voltage drop in the ground that is referred to in cathodic protection work as the IR drop in the soil. The IR drop in science is the potential variations that result from the passage of charges from the working electrode to the return electrode. It can be seen in the diagram that the IR drop between the working electrode and the reference reaction, hydrogen platinum reaction, is avoided by measuring at the interface between the metal and the electrode. This measurement is not possible in field conditions without an arrangement of electrodes that is now available in the Alexander cell, as shown in this picture. Science requires the codification of repeatedly observable experiments or repeatedly observed events in real life. Science is evidence-based. Engineers must conform to the codified laws of nature or their engineering will fail, as it does in applied cathodic protection at present.